This is video 6H for the Year 7 Mathematics course. In this video, we're going to be covering the theory behind one quantity as a fraction of another, under the topic of fractions. Specifically, we're going to explore why we express quantities as fractions of one another, how to express one quantity as a fraction of another quantity, equal units, and then we're going to cover some example questions. Oftentimes, when we're talking about fractions, one of the most common uses of fractions is a way for us to compare different quantities. What I mean by that is we often represent one quantity as a fraction of another in order to compare how big or how small they are. So what I mean by this is, you could say, for example, that Jimmy is half the height of Sam, or that Bob earns 2/3 the amount of Zeke. So in both of these examples here, we can see that we're comparing the sizes of two different quantities by saying that one of them is some fraction of the other. In the first one, we're saying that Jimmy's height is half the height of Sam. In the second example, we're saying that the amount that Bob earns is 2/3 the amount that Zeke earns. And I'm sure you've probably heard of different ways that people have compared two different quantities in the past as well, by representing one as a fraction of the other. Now, in order to do this from a mathematical perspective, we write the quantities as the numerator and the denominator of a fraction, which we then write in lowest terms. Now what we're going to do is give a very general idea as to how we would actually compose this fraction. So let's say we've got the quantities a and b, and we want to write a as a fraction of b. Then the way that we would do this is we would write the fraction of a over b and then simplify it into lowest terms. Now, the really key terminology here that you're going to see pop up again and again and again is this phrase of as a fraction. Because pretty much the thing to the left of that statement should be in the numerator. The thing to the right of that phrase is going to be the denominator. Because making sure that you get these two things the right way around is very critical. If you put them the wrong way around, you're going to get a very different answer than what you should expect. Now, the final really important thing here to understand as well is that when, of course, we're talking about real life quantities, often we're also working with units. So for example, when we're talking about length, we could be working with millimeters, centimeters, meters, kilometers, and so on. If we were talking about mass, we could be talking about grams, kilograms, and so on. When we are doing this kind of process here, your two quantities must have the same units. If you are not given them with the same units, your first job should be to convert one of them to have the same units as the other. So the first thing that you should check whenever you're doing a question like this is always whether the two quantities that you're working with have the same units. If they do, then go for this process here. If they don't, then your next job should be to convert one of them to have the exact same units as the other, and then go from there. Alrighty, with that being said, let's now go through a few examples of how we can write quantities as fractions of one another. So the first example that we're going to consider is to write 5 kilograms as a fraction of 15 kilograms. Okay, so our two quantities here are 5 kilograms and 15 kilograms. Both of these have the exact same units, so we are good to go. Notice the terminology is specifically saying to write 5 kilograms as a fraction of 15 kilograms, which means that this 5 is going to get put on the top of a fraction, the 15 gets put on the bottom. So our fraction is 5 over 15. We now need to try and simplify this. We can do this by dividing both the top and bottom by 5. And in doing so, we get 1 over 3. So what this here therefore tells us is that 5 kilograms is 1/3 of 15 kilograms. Second example is to write 110 centimeters as a fraction of 2 meters. Okay, so in this particular case, our two quantities are 110 centimeters and 2 meters. Immediately, the first thing that we can see is that these two quantities do not have the same units. We've got centimeters for one and meters for the other. So the first thing that we should do here is turn this 2 meters into centimeters, which, if you do that conversion, will be 200 centimeters. Now, notice the terminology of this question. We're being asked to write 110 centimeters as a fraction of 200 centimeters. So in this case, the fraction that we're going to be working with is 110 divided by 200. Now let's simplify. We can divide both the top and bottom by 10, and in doing so, we're then left with 11 over 20. So what this here therefore tells us is that 110 centimeters is 11/20ths of 2 meters. Third and final example that we're going to consider is to write 60 cents as a fraction of $5.50. Alrighty, so the two quantities that we're working with are 60 cents and $5.50. Of course, these two quantities don't have the same units, so we can first of all convert this $5.50 into cents, which will be 550 cents. Now let's have a look at the terminology of this question. It's saying to write 60 cents as a fraction of 550 cents. So the 60 is going to go on the top, and then 550 is going to go on the bottom. And now we want to simplify this fraction. We can divide both the top and bottom by 10, which then leaves us with 6 over 55. And so therefore, what this answer here tells us is that 60 cents is 6/55ths of $5.50. Alrighty, let's summarize what we've learnt today. So in this video, we explored how to write one quantity as a fraction of another. In order to write a quantity A as a fraction of a quantity B, we write the fraction A over B and then write in lowest terms. To do this, the two quantities must have the same units. We then applied this idea to some example questions. And that's it for now. See you in the next video.